Module 4 review, right? Yep. Jill has 11 1/4 ounce of candy. She wants to share it equally with 12 friends. How many ounces of candy should each friend get? So, again, just to identify the operation on this one, she's going to share it equally, which indicates we are using division. So we do need to know how much she starts with, and that's this 11 1/4 ounces of candy. Okay? What's she dividing it by? Well, 12 friends. So, by the way, that means we'll also include that either she's one of the 12 friends or she's just giving it away to all 12 friends. She's not, it shouldn't be 13 for any reason at this point, okay? So how many ounces of candy should she get? This should tell us 11 1/4. First thing I would want to do myself on this is to change the 11 1/4 into the improper fraction with some cycle method. So that's 11 times 4, which is 44, and then add the 1 numerator to make this 45 fourths. Now I'll look at the divide by 12. Yeah, it's true that I don't want to use division with this fraction. And I'm going to make that 12 over 1 because I'm working with fractions. It's just, I don't want to divide. So I'm going to take my 45 fourths. And I'm going to change the operation of multiplication by reciprocating the fraction 12 over 1 to make it 1 over 12. All right, 45 and 12. Yeah, we could cross simplify that, by the way. So 45 is divisible by 3 and 12 is divisible by 3. How do I know 45 is divisible by 3? Because 4 plus 5 is 9 right there. So I know it's divisible by 3. We'll look at how to figure that out. But 12 divided by 3 is 4 in the denominator. At least that much, okay? But I want to look at this 45 divided by 3 as well. What do we get from that? Cross simplification. 45 divided by 3. 3 goes into 4 once. 1 times 3 is 3. Subtract. 1 remaining. Drop to 5. 3 goes into 15 5 times. 15. So let's see, what do I get? That was 15 from 45 divided by 3. And that should be simplified right there. But let's find out. In the numerator, I got 15 times 1, which is 15. In the denominator, I got 4 times 4, which is 16. That's a proper fraction right there. I just need to specify the label for this answer. And yeah, up there it says that it was how many ounces of candy. You can put OZ. If you want to spell out ounces, that's fine, but this should do. On this problem, we got this set up with area equals length times width. They gave us length and width. It's area because it's how much carpet. But I'm going to show both answers for this one. I'm going to show the improper fraction first, as we usually would, doing this by hand. And then we'll convert that back into a mixed number, just in case on the quiz or assignment it asks for the mixed number. This one doesn't specify, by the way, so I would be okay with leaving the mixed or the improper fraction. But I can't guarantee it won't ask for the mixed number on the assignment. Okay, so let's go ahead and use some cycle method to change. I'm going to start with the 9 6/11 there. Let's try this though. 9 6/11. Change it into a improper fraction, right? So that'd be 9 times 11, which is 99. And then add 6 numerator there gives us 5, carry the 1, 15 by the way. 9 plus 6 is 15. What am I doing? 9 plus 1, that's 105. There we go. 105. So that's my new numerator there, 105. Remember, the denominator doesn't change, so it's 105 elevenths. We're going to multiply this by 2 1/5, but let's change it into its improper fraction. So that would be 2 times 5, which is 10. Then add the 1 numerator from cycle method to make that numerator 11. So then this other one becomes 11 fifths. Oh, that's very nice. I can see that the 11s just are both divisible by 11. So I can use some cross simplification on this one. I know 105 is divisible by 5, but I'll go ahead and show this out first. So our new fraction, my multiplication, 105 times 1 is 105 in the numerator. In the denominator, 1 times 5 is 5. So really, all I've got to do now is take 105 and divide it by 5. And this should be my area right here, okay? So 5 won't go into 1, but it will go into 10. 2 times 5 is 10. That zeroes out, drop to 5. 5 times 5 is, 5 goes into 5 once. So yeah, nothing remaining on this one. And we can see up there that my final quotient is 21. I'll just need to label it right, so I'm going to make that in square feet. 21 square feet. This one may be a little bit more direct, and we've seen a problem like this already, so hopefully that's not too bad. All right, now we got some fraction and mixed number multiplication on this. So it's already multiplication, so we don't need to worry about reciprocating any of the fractions, but I do worry about looking at that 1 and 5/21. So I do want that to be an improper fraction. So we're going to use some cycle method on this one in the numerator. My new numerator, the denominator rather, is not going to change, but in the numerator I'd have 1 times 21, which is 21. Then add another 5 numerator there, makes that 26. So I end up with 26 21ths. The 21 fifths, yeah, that didn't change at all. It's already an improper fraction. Hey, what do you know? There is some cross simplification on this one. And I would usually say multiply at this point, but these match, so hopefully the cross simplification is not too bad. 21 divided by 21 is 1. So 21 divided by 21 is 1. Yep, now I can multiply. The numerator is 1 times 26 is 26. And then in the denominator, 5 times 1 is 5. So I get 26 fifths. Let's see, did it say it wants the answer in simplest form? So again, that should work right there, 26 fifths. But just in case it does want the mixed number on that one, you can do 26 divided by 5, which goes into a 5 times 5 times 5 is 25. Subtract, you get a remainder of 1. So that would end up being, as a mixed number, 5, and 1 remaining out of 5 parts. I can do better 5 than that. Yeah, and we're not looking at a word problem anymore, so no need a label here. With problems like this one that have 3 different factors, my inclination is to use some cross simplification because I think it goes much better for us. And the first one that I noticed, at least for me, was 4 and 16. Let's make this a little bit bigger. Now, maybe you didn't notice 4 and 16, you saw 6 and 12. Why am I using these? Because some of you could say, well, 6 and 26 could simplify, and that's true, you could, by the way. But I just noticed that 12 is a multiple of 6, and I see both numbers there, one in the numerator, one in the denominator, so I can simplify accordingly, okay? They're both divisible by 6. 6 divided by 6 is 1. 12 divided by 6 is 2, okay? So that simplified that 6 down into a 1, which is very nice. The same thing will happen with 4 and 16. I see that 16 is a multiple of 4, so I can divide 4 and 16 by 4. In the numerator, 4 divided by 4 is 1. In the denominator, 16 divided by 4 is 4. Okay? And at this point, I see the 26. It's divisible by 2, but not 3. 9 is only divisible by 3. So this, as of right now, that should be fully simplified. And we can see, at least for those of you that are multiplying the numerators and then the denominators from the original number, you're going to get some big values, which will then require, I would say, at least 3 different simplifications at that point, which is what I'm actually trying to avoid here. Could you still use that method? Of course you could. You'll never get stuff marked wrong for using the wrong method, okay? So let's look at our new numerator on this one. I'd have 1 times 1, which is 1. And then 1 times 9 is 9. So that's my new numerator, 9. In the denominator, I've got 26 times 2. Stack and multiply this just in case we need it. 2 times 6 is 12. Carry the 1. 2 times 2 is 4, but add the 1 makes that 5, 52. But I still got to multiply it by another 4 there, so multiply that by 4. 4 times 2 is 8. 4 times 5 is 20. So that ends up being 208 is my new denominator. And again, like we said, you could check to see if 208 is divisible by 3. I know 9 is, but it's 208. Well, 2 plus 0 is 2, plus 8 is 10, and 10 is not divisible by 3, which means that this is as far simplified as we can make this problem. Some division for us. 5 3/4 divided by 9. And just like we've seen with these type of problems with mixed numbers, pretty much our first objective is to change the mixed number into an improper fraction with cycle method, right? Now, I did say to write the answer as a fraction. I don't know. I guess we should end up with a proper fraction on this one. Let's find out, okay? But for me, I'm going to change the 5 3/4 into an improper fraction. I'm not worried about changing the operation of multiplication yet. I will, but not yet. So 5 3/4, again, the denominator is going to stay the same in fourths. But what is my new numerator? Well, 5 times 4, just with cycle method, that'd be 20. Adding the 3 numerator makes that 23. So it's 23 fourths. Then we'll divide that by 9. Okay, but I do not want to divide by 9. I'd rather divide by 9 over 1, which we can show right now. And I don't like division with fractions. I would rather instead multiply the fraction. So I'm going to take my 23 fourths, and I'm going to change this operation from division to multiplication. I just got to remember to reciprocate that divisor fraction. So that's 9 over 1 becomes 1 over 9. Oh, well, I don't see any cross simplification that can occur. So we should just end up with a proper fraction here in the numerator. 23 times 1 is 23. In the denominator, 4 times 9 is 36. So 23 over 36 appears to be our final answer on this one. 25 times 7 over 125. And you know what? I'm just going to make that 25 over 1. Let's just multiply these, okay? 25 times 7. Let's see what we get from that. 25 times 7. 5 times 7 is 35. Carry the 3. 7 times 2 is 14, but add the 3 is 17. So that's 175. Now, over in the denominator, 1 times 125. Yeah, anything times 1 is itself, okay? So we see this. I mean, there's fairly large numbers, by the way, but I know that they both end in 5s, so I can just divide them by 5. And yeah, I'm going to resort to some long division for this, but 175 divided by 5. Some of you know you should have divided by a bigger number there, and that's fine if you did. But for those of you that don't, here we go. 5 won't go to 1, but 17 3 times. 3 times 5 is 15. So that's 2 remaining. Drop the 5 and make it 25. 5 goes into 25 5 times. So my new numerator is 35. My new denominator, 125 divided by 5. So 5 goes into 12 2 times. 2 times 5 is 10. 2 remaining, drop the 5. 5 goes into 25 5 times, exactly. So I got 35 over 25. But again, these numbers end in 5, which means that these are further simplifiable by 5. I shouldn't need long division anymore, hopefully. But 35 divided by 5 in the numerator is 7. 25 divided by 5 in the denominator is 5. 7 fifths. And the original problem said it wants the answer in simplest form. That's fair enough. Just in case, though, it asks for the mixed number, you could do 7 divided by 5. I'm going to skip the long division on this, though. It's just 1 2/5. It's the same answer. Remember though that on the quiz or assignment, if it does not specify that it wants the answer as a mixed number or an improper fraction, either one should work. Here, 64-ounce bag of Skittles holds 2,024 Skittles. I don't know how true this is, by the way, but Mara's family has eaten 3/4 of the bag. How many Skittles have they eaten? So this one's asking how many Skittles, which indicates that we don't actually need the ounces for this one. Okay. All we're going to do is we're going to take the amount of Skittles that is in the bag, the 2,024, and they're going to eat 3/4 of. Of is the key word here. That's multiplication with this 3/4. So multiply by 3/4. I'll make it over 1 there. And you know what? You could cross simplify here, but I'm not going to. I don't know why, but I'm just not going to. In the numerator, I got 2,024 times 3. 3 times 4 is 12. Carry the 1. 3 times 2 is 6, but add the 1 is 7. 3 times 0 is 0. 3 times 2 is 6. 6,072 in the numerator. In the denominator, 1 times 4 is 4. Okay, so I'm going to take this 6,072 and divide it by 4. That's not too bad. 4 goes into 6 once. 1 times 4 is 4. Subtract 2 remaining, drop to 0. 4 goes into 25 times. 5 times 4 is 20, exactly, so that's going to zero that out. How many times is 4 going to 7? Once. 1 times 4 is 4, subtract, and we got 3 remaining there. Drop the 2 from the 1's place value, that's our final place value. 4 goes into 32 8 times. So yeah, nothing remaining on this one. There we go. So, the original question here, how many Skittles have they eaten? Well, after we did the division, we found 1,518. It seems like a lot of Skittles, but, you know, I guess it didn't really specify how long it took. Like, if that was overnight, it's like, whoa, during a movie night or something like that, that's a lot of Skittles right there. Could be bouncing off the wall for days, but it's just a math problem. And again, it's not specifying what simplest form is. I'm going to show both answers, though, as a mixed number and an improper fraction, just in case. It does specify on the homework. All right. So I got 48 divided by 126 over 8. I'm going to make that 48 over 1, actually, which then allows me to change this operation into multiplication. Right. But if I do that, I gotta flip this fraction, reciprocate it into 8 over 126. Now, for me, I would notice that 8 and 126 actually can be simplified. Let's say that you didn't notice that, then okay, well then you'd probably just do some straight multiplication on this, right? So I'd say multiply your numerators, 48 times 8. Let's see what we get from that. I'm going to stack it because I need it. But 8 times 8 is 64, carry the 6. 8 times 4 is, 32, what am I thinking? 32 plus the 6 makes that 38. So that's a new numerator of 384. In the denominator, I got 1 times 126, which is 126. And let's see, will 126 go on to 384? It appears not evenly anyway. And so I'm just going to simplify this fraction. I see that they're both divisible by 2 at least. So how do I know that? Because the 1's place value is even numbers right there. So 384, let's see, 384 divided by 2. 2 goes into 3 once. 1 times 2 is 2. Subtract, there's 1 remaining. Drop the 8 to make it 18. That's 9 times. 2 is 18. Drop the 4. 2 goes into 4 2 times. So that's a 192 new numerator. In the denominator, though, 126 divided by 2. 2 goes into 12 6 times. That's a 12 right there. How many times is 2 going to 6? 3 times. 63. All right, now I can see that the numbers are no longer divisible by 2, but let's see if they're divisible by 3. And we'll do that by adding the numbers together. So that's a 1 plus 9 plus 2 in the numerator. That's 12. So that's divisible by 3. But what about the 63 denominator? Well, 6 plus 3 is 9, and that's divisible by 3 as well. So that means that 192 is divisible by 3 here, and 63 is as well. This will be my new fraction. What do I get from that numerator? 192 divided by 3. 3 goes into 19 6 times. 6 times 3 is 18. 1 left over, drop the 2. 3 goes into 12 4 times, 64. In the denominator, 63 divided by 3. 3 goes into 6 2 times. That zeroes that out. 3 goes into 3 1 times, 21. Right? And so 64 is not divisible by 3. 21 is. 64 is divisible by 2, but 21 is not. And so I don't see that I have any other common factors. Let's see. 21 is divisible by 7, but 64 is not. So this appears to be my final answer in improper fraction format. But if I wanted to change this into a mixed number, right, we'd have to use some long division here. 4. 21 goes into 64. That should be 3 times 21. I'm skipping a little bit of the math here, but that's 63 there. So a remainder of 1, right? So that ends up being 3 and 1 21. Either one of these should work when it does not specify how it wants the answer. But it is simplified, by the way. Both of them are. And so, yeah. There we go. Some more division on this. That's okay. And so, well, let's go ahead and change this into a multiplication problem. So we got 12 over 99. We're going to change this to multiplication by reciprocating that divisor, 108 over 36, which then becomes 36 over 108. Okay, now a couple things on this is I can see that 36 and 108, they're both divisible by 12 actually. So that's actually the first thing I'm going to do on this one is look at these two numbers and say, hey, these are both divisible by 12. Why am I doing this? Because I don't really want to deal with the big numbers. And I see that there is some simplification. At the very least, 6 and 8 are divisible by 2. So even though if it takes you more steps to do this to get the final answer here, it's not a problem, okay? But at least for the 36 over 108, they're both divisible by 12. 36 divided by 12 is 3. Oops. And 108 divided by 12 is 9. So 3/9. Oh, that's pretty nice. Because, well, 3 over 9, that would be divisible by 3, both of them. But I'm going to need some more space, actually. So there we go, 3 and 9. That's going to simplify into 1/3 if you just divided these both by 3, right? Okay. But what about that 12 over 99? Well, 12 is divisible by 2. 99 is not. 12 is divisible at least by 3, but, oh, 99 is. Okay. Well, I don't know. For me, really, I would probably want to see this as 12 over 99 down here. It was there the whole time, right? Just now I'm showing it. I would probably even cross simplify the 12 and the 3 right there. 12 divided by 3 is 4, and then 3 divided by 3 is 1. Okay, and this makes the multiplication much easier for us. In the numerator, 4 times 1 is 4. In the denominator, 99 times 1 is 99. And yeah, even though 4 is divisible by 2, 99 is not. I was talking about 12 was divisible by 3, but I just divided it with the 3 with cross simplification. But again, it's important for you to see that if you can, it's not necessarily cross simplification at that point, it's just simplification of the fractions. You can do that if you want. But yeah, that's about as simple as I can make this problem on this one, 4 out of 99, okay? So it looks like, if you multiply the 12 and 36 and the 99 and 108, you'd get some big numbers out of that. But then you could have divided by 2 and then 2 again and then probably 3 and a 3. And then you'd ended up with 4 over 99. Same answer, should get the same answer either way. So we'll write this one in simplest form and see what we get. For me, on this one, I would notice the zeros on the end of that second fraction right there, which then makes it 9 over 24. So not everyone would need to show this part right here, but I'm going to. And it's still being multiplied by 62 over 150. All right, now looking for any further cross simplification. I know 9 and 24, they're both divisible by 3, so I'm going to go ahead and do that. And these are both divisible by 3 as well. So I kind of first, by crossing out the zeros, means I divided by 10. But now dividing by 3, 9 divided by 3 is 3. 24 divided by 3 is 8, 3/8. Okay, now I'm still multiplying this by 62 over 150. And let's see. I see the 62 and 150. They're both divisible by 2. I don't know how much that really helps us, but you know what? I'm going to skip it just because it's kind of getting a little bit more difficult there. So let's go ahead and multiply the numerators. 62 times 3. What do we get? 62 times 3. 3 times 2 is 6. 3 times 6 is 18. 186. That's my new numerator. All over 150 times 8 right there. 150 times 8. 8 times 0 is 0. 8 times 5 is 40. Carry the 4. 8 times 1 is 8. But add the 4 makes that 12. 1,200. So 186 over 1,200. Yeah, I can see that these are at least divisible by 2 for now. And what do we get then? Well, that'd be 186 divided by 2. 2 goes in 18, 9 times 2 is 18. So 6, drop the 6, 2 goes into 6 3 times. 93. That was my numerator. And then in the denominator, 1,200 divided by 2. 2 goes into 12 6 times. That's 12. Drop your 0. It's not going to go into those zeros. So 600. Well, at this point, I see that 93 and 600. 600 is divisible by 3. 9 plus 3 is 12, so that's divisible by 3 as well. So let's go ahead and do that just, with a little bit more space here. Let's go and divide these by 3 then. And I'll start with the denominator just because I think it's easier on this one. But 600 divided by 3, 6 divided by 3 is 2. Just tack on the 2 zeros, right? But the 93 divided by 3, that one may be a little bit more complicated. So you could do that pretty quick in your head. That's okay. 3 goes into 9 3 times. 3 times 3 is 9. Zeros that out. Drop the 3 in the ones place value. 3 goes into 3 once. 31. That's exact, by the way. 31 is prime, and 200 is not divisible by 31. So it looks like this is our final simplified answer. This one, we do have the exponent right there. And, the first thing I would probably want to do myself on this one is change that 2 and 7/6 into an improper fraction. So that's what I'm going to do. Do you have to do it? No, you can do it later. It's not going to matter. We'll apply the exponent of 2, though, afterwards. So for me, I would say, well, 2 times 7 is 14. Add the 6 numerator to make that 27s. Okay? But all this is raised to the power of 2, which means that really I'm looking at 27ths. Let's see if I can do this. 27ths multiplied by 27ths. Just like this, okay? Now, I don't see anything no way to simplify this, so I'm just going to multiply straight across. In the numerator, 20 times 20, that'd be 2 zeros. 2 times 2 is 4. In the denominator, 7 times 7 is 49, okay? Now, in the original problem, it said to write the answer in simplest form, which I've done, but just in case it wants the mixed number on this one, we'll go and figure that out. 449. Without showing the multiples on this one, it should go into 400 8 times there. Okay. And so let's see, what would that be? 300. And let me make sure I'm doing this. That's good. So 392, when I subtract, I make the 10 minus 2 is 8. That's on my remainder, which I need. But I'd have to borrow from the 40 to make that 39. So that zeroes out. So that's a remainder of 8. So 449ths is the same as 8. And a remainder of 8, 49ths. Okay, either one of these work. Again, for me, I would say, since it didn't specify, that I don't really need to change it to a mixed number. So I personally would write the 400 over 49. But if it did specify that it wanted a mixed number, yep, you'd use some long division like I did right there. All right, here we go. This one's nice. It's a proper fraction, but it's raised to the power of 3, so a little bit more multiplication. That's not a big deal, hopefully. Yeah, let's go and make this a little bit bigger. And we're going to take this 2/3. I'll use some technology here, and we're going to multiply it by itself 3 times. There we go. Thank you, technology. So I don't see any cross simplification that can occur, so we're just going to multiply this straight across. First 2 times 2 is 4 times 2. The last 2 there is 8. So that's my new numerator. In the denominator, 3 times 3 is 9. 9 times 3 is 27. 8 27ths. Hey, that one, I like that one much better than that last problem, but it's still not too bad. All right, a little bit more division on this one. And I think we see problems like this, and I want to say that we talked about this before, but one thing you would not want to do on this one is mistake it for multiplication with the cross simplification of the 6's. That's what you should not do. Okay, so do not cross simplify these 6's like this, okay? We need to first change this into a multiplication problem, which it is not yet. So I'm going to take my 6/13, keep it, change my operation to multiplication by reciprocating the divisor. So that's now 6/5. And yeah, I don't see any cross simplification here, so I'm just going to multiply straight across. In the numerator, 6 times 6 is 36. In the denominator, 13 times 5, I'll stack it, multiply it, not that everyone needs to, but 3 times 5 is 15, carry the 1. 5 times 1 is 5, but add the 1 to the 6, 65. Yep, and since we couldn't cross simplify before, this is not simplifiable, so that's just our final answer right there. And yeah, this is as simple as we can make it. We would not want to change this to a mixed number like 0 and 36/65. All right, and then some straight multiplication on this one. I believe we will end up with a proper fraction on this one. So when it says simplest form, we're just looking for the proper fraction on this. No cross simplification here, so 5 times 9 in the numerator is 45. In the denominator, though, 8 times 11 is 88. Yep, that can't be simplified any further, so that's just it right there. So the gas tank holds 13 gallons of gas, and it is 1/4 full. So how much gas is in the tank? Well, we're going to take this 13. It says it is 1/4 full. I don't know. Seems weird, worded slightly weird. Maybe it's just because I typed it in. But we know we're going to start with the full tank would be 13 gallons. It's only 1/4 full. Now, we did talk about this before. You could say, well, it's a fraction. Oh, not the one there, but it would equal something where it's 1 out of 4 parts, right? Like this. The problem with this one, even if you set it up like this, it's like, well, what do you multiply 4 by to get 13? That's going to be a fraction, by the way. And if you're okay with working with those fractions, that's fine. So I prefer to look at this as though you're starting with 13 gallons, and it's 1/4 of the way full. And so I would just multiply it by 1/4 on this one, making the 13 over 1. And you see that this, I think that this setup right here, as long as you understand that you're using multiplication because it's 1/4 of the tank, I think that's the way it was worded in the problems that we did for that section. In that case, we know that it's multiplication, but this multiplication becomes easier because I'm just multiplying by 1. In the numerator, 13 times 1 is 13. In the denominator, 1 times 4 is 4. Now that's gallons right there. And if it's okay with improper fractions, which I would assume it is, I would keep that way. If you needed to change this into a mixed number, 13 divided by 4 long division, you're going to get 3 1/4 gallons.